Alright. I think we're streaming, maybe. Yeah. Yeah, we're up. Good. Welcome back. It's been a little bit of time. I have just been so busy, I have not had any time to get into doing any of these amps, and quite honestly, I haven't had the energy to do so either. Uh, this component shortage is it's really killing me at work. It's killing everybody, but it's killing me, and I'm just spending so much time doing circuits and boards at work that I just, when I get home, I just don't want to do it. I want to relax and do nothing, so do other things. But I finally got some parts in. I'm not gonna get it, but I got a bag of capacitors in, so that should allow me to finish at least these few that I have on the bench and get them back out of here. Um, I got a couple that need to get shipped out. If you're waiting on shipping, I apologize, especially on international orders, because I have to take those personally up to the office. I can't just make a label at home, so um, it requires me to take a day off of work. So that's what the delay is for. So if you're waiting, I apologize. I'll get your stuff out to you, but let's let's get into this and get going on it. And I'm out of coffee, so I'm gonna have to take a break here and go do a refill. But we have two of these. We did the twin, or we did this one. I was waiting on these small capacitors down here. Those are installed now. This one is complete, so we're gonna do the other one. But I just wanted to do a quick update on what we're waiting for on this guy. And the capacitor shortage has gotten really bad. I mean, it's to the point where it's threatening to shut down production at work, so we know it's bad. But here's the next one. So, I can see we got some bad glue right there. That's going to be a problem. Let's zoom in on that, and you can see why. Oh, if I can figure out how to work my buttons here. Oh yeah, macro mode. I didn't even know I had that. This is why these amps fail, because somebody thought it would be a good idea to put this glue up on here, and I mean, look at it. It's turned brown and like chalky and conductive. So this is the amp killer right there. You can see that it's just crusty and bad. The other glue on here looks okay. Actually, by the caps, it's starting to look a little questionable. But the rest of the spots don't look terrible. I mean, either way, we're going to get it all off. But that's what we're working with tonight. So, I mean, you can see back here, that's good glue still. Only, where there's heat is usually where the glue gets bad. And this board gets pretty hot, so let's get into it. Get into it and get her done. And if you send me messages and emails, I apologize. I haven't replied to any of those either. Like, as I tell everybody, I do this as a hobby. This is not a business. This is, my free time. So if you're on the waiting list, and I mean, some of you have been on that waiting list for a while, like, just keep in mind that I'm doing this for fun. I don't do this, commercially. So if you're okay with waiting till you can get to me, hey, that's great. You might have to wait a year. Let's see a little message on here. He needs a fuse. We can look at that with a smiley face and everything. We'll get you a fuse. I'll just make sure to bill you for it. Just kidding. I don't charge for fuses. Although if the prices start going up anymore, I might have to. But yeah, I mean, I'm gonna try and get through this list. I get on a roll here and then just, you know, life happens and I get sidetracked and I can't keep going at it like I was, so we'll see how far I get this week. Hopefully I can get a few done. I really would like to do one a day. If I could stick with one a day, I'd be in good shape. Either that or, you know, go to a 4-day work week and then I could have a whole day to dedicate to repairs. That would be the way to do it. Alright, let's get into this power supply. You know, it's gonna kind of be the same deal. I expect the fuse is gonna be bad, but we gotta check the inrush. The little green thing. And I'm just looking for signs of burn or blowout. And usually if the owner does not continuously replace the fuse or put a higher value fuse in there, the inrush does not go bad unless there is like a surge or something. This one looks good. So we got to take the PDC board out. The FETs are going to guaranteed to be shorted. Those got to come out. Let's see which one it is. Do a quick little poke on there, and I know they're bad, I just don't know which one. If they're not bad, I'll be bamboozled. Yeah, there it is. This guy's showing shorted. And then there's always one. Usually that's bad, so we gotta replace one of the FETs on there. No big deal. Glue on top of these Carly caps, we can leave that. Glue down here, we can probably leave that as long as it's not touching the legs of the capacitor. I don't know, let's just get into it. Let's start desoldering and taking things off. One of the big holdups too is I didn't have these caps. I ran out of 200 volt caps, so I had to get more caps, and it's getting harder and harder to find these things, and they're getting more and more expensive. And I'm pretty sure my prices are the cheapest out of any of the repair options that are out there. But if these parts keep going up and up and up and crazy like that, I don't know how much longer I'm going to be able to remain competitive. But we'll see. Hopefully things will get back to some form of normalcy. It sucks not being able. I used to be able to get parts overnight, and now it you know, takes several days, sometimes weeks, sometimes months. I got a guy waiting for JBL. He's waiting till August. Alright, we're heating up the solder sucker here. Board's in pretty good shape. I don't really see anything that makes me nervous. Hopefully this will just be a cleanup. Quick repair. I'm going to test this board. I've learned that lesson a few times. It's always good to throw that in the board tester. One of these days, actually I shouldn't say days, one of these years, I'll make an official board tester for these boards instead of just using a beat up old amp, but for right now that works. It'd be nice to just plug the board in and have, you know, a little screen tell me actually what's wrong with it. And I have some ideas on how to do that, but it takes time. And time is something I have none of. the glue around these caps is kind of fresh, so they're going to be a little hard to get out. The reason I'm double clearing the holes is because the leaded solder is really hard to suck out of these holes when you don't have good airflow. Just requires a lot more heat. So by doing it twice, you make it a little easier on yourself. This one should come off with a little persuasion now. Like that. Quick little sharp blow. That's how I do it anyways. If you do that and you smash somebody's amp, don't say you learned it from me, but I've been doing it for a while and it seems to work. You just have to make sure your holes are cleaned very good. Glad I don't live in California. I'd probably get sued for doing this repair if I lived there. I don't think you're allowed to use lead for anything. That one looks pretty good. Alright, let's get this one out. So we have a little bit of glue burn in the back here by the resistor. You can kind of see it starting to get a little bit brown. A little funky, but we'll fix that. We'll get that out of there. I'm going to take off this other cap and then switch to my shorter tip. Keep chugging away. I like these amps, the RW. I like the RW series subwoofers. They're pretty good. RW, RSW. I have an RW-10, not the digital version, just a regular. I need to use that more often. It's a good sounding sub. I've used it for many years. I like it. I'm on this kick now, though, where I want to build my own speakers, so I don't know how much longer I'll have Klipsch subs. I have so many Sunfires, I really like the Sunfires. I don't have a huge space, and a 10-inch Sunfire, like, I mean, it could shatter your ears. So I think I'm trending towards going with a dual 10-inch Sunfire setup with some custom-built speakers. Spent a little too much time surfing around on HT Guide, and they have some really good designs over there. And I don't know. I think I might take a shot at building a couple of them. I mean, I guess I could buy something, but I don't think that would be nearly as fun. Probably cheaper in the long run to just buy it, but I don't know. I bought some exciters, and I'm thinking about making a pair of the DML speakers. So I don't know. I got a lot of ideas. It all comes down to how much time I have to do any of these. And every idea I have or side project I have takes away from amp repair time. So I got to keep that in mind too. This is my least favorite part, getting all this darn glue off without destroying the board. It's not too bad if you have a razor blade, but sometimes when you get around these like little resistors and stuff, it's kind of a pain to get off. I like to get it off in one chunk if I can. I got lucky tonight. The amp repair gods are in my favor. I'm trying not to be too aggressive on the board, you know, just enough to get most of the glue residue off. You don't have to get it all off. Sometimes getting it all off is, you do more damage than good. It doesn't really have to look pretty, you know, you just have to make sure that you got it. This resistor here is kind of cooked, but luckily it's only a jumper, so that doesn't matter. The goal is just to make sure that it's you know, not going to cause any more shorts. So I mean, yeah, there's some little scratches and scrapes on there. In the camera you can't really tell, but you know, there's little bits of like residue, you know, by this trace right here. You can see a little bit, and you know, I can keep scraping that until I get it all off. But what's going to happen is eventually you're going to scrape the solder mask off, and then you're going to expose you know, the bottom of the cap potentially to that, and underneath this thin piece of plastic is metal, and if it touches, you know, a hot trace, you can cause a short there. So you don't want to, you know, go crazy and expose all that metal down there if you don't have to. Just get the residue off, make sure it's not going to cause any shorts. You know, clean off what you can, and you'll be in good shape. So the two major areas really are just the caps. Like these little caps look good. There's a little bit over here. I'll clean off some of that. I'm not going to take it all off because it is kind of supporting this little blue guy there. On top of the Carleys is fine. On these standoffs is okay. And on top of all this stuff over here is okay. That doesn't cause any problems either. So we're going to have to give a really good cleaning to the PDC board. And then a recap, and this power supply should come back on. Unless the PDC board's dead, but we'll find that out as soon as I get to test it. So let's just keep pulling this glue off for now. I know you guys can't really see, but that's alright. You get the idea of what I'm doing. If you really want to see the glue removal, you can tell me in the comments and I'll figure out a different camera angle. I don't think it's exciting enough to warrant that, but hey, you never know. Maybe somebody's new to the channel and they want to see it. There's a lot of glue on this one, but it's still one of the better ones that I've seen. You know, I don't have any major concerns with massive blobs on there. It's mostly just little stuff in places it shouldn't be. Just anywhere where there can be a short, that's where you got to get it off of. Even around the body of the big caps, it's really not as important, but I don't know, for the sake of being thorough, you know, an extra few minutes, it doesn't hurt to heat the glue and just get it off. be careful when you start getting to some of the components. You can, I mean, if you're a little too strong with the razor blade, you'll literally just slice the components right off the board. So you can be a little aggressive, just don't get crazy with it. Otherwise, you're making more work for yourself, and then you got to source parts that you probably don't have. Best way to do it is dental picks. It's the most work, but it does the best job cleaning them. Especially this like scraper one. I don't know what this thing's called. I need to buy some more of these. This is a great tool. It's like not super sharp, but it's sharp enough to get the glue off, and it does a really good job. And it has two different angles on the blade, so you can really get into some funky areas with it. Be gentle when you're cleaning your caps. You don't want to go crazy on those. That should be it for most of the glue. I'm sure there's still some boogers and chunks in there, but... Alright. MacBook Pro. Capacitor availability is horrible. I mean, I'm not finding any Tier 1 brands really anywhere. It's just all junk capacitors. You know, a lot of the values I use in Nichicon, Rubicon, Panasonic, I mean, there's just nothing left. I bought the last 15 of these 200 volt caps from DigiKey. Nobody else has them in stock, so it's it seems to be getting worse and worse and worse and worse. And that sucks, because I mean I'm waiting on a back order cap for this JBL amp I'm working on, and the earliest they said it'll be in is August. That's a long time to wait for a cap to come in. But I mean, there's literally nothing I can do. Like, my hands are tied. So I'm gonna, you know, run through what I got, and when I run out, I'm just gonna have to stop and wait. And I know that sucks, but what can you do? There, while I'm waiting for that to heat up. This is one of my recent purchases, and yeah, these are the last 15 caps. These UVY series. And these are needed. Actually, I don't know if I have to use those on this amp. I think I can. Yeah, I can use the snap ends. But the diameter's the important part. Certain amps can't use the thicker diameter caps, and you really run into problems there. And snap ends, I have 2 snap ends left. No, 3. I have a short and a skinny and tall. I don't have, let's see, this is that's 1,000. I need to check and make sure I have the caps just to complete this one. I think I should. I know I have some thousands saved. Yep. There's my 3 caps. I'm gonna have to check those and make sure I can order some. Otherwise, I'm gonna be in trouble with those. All the oddball ones I seem to have a decent supply of, like 560s and 680s and 1500s, 4700. All the big boys, I have, but the common ones that Klipsch uses, I don't have enough stock of those. And I mean, it's been a couple weeks since I checked supply, so maybe they're back in supply. I don't know. It'd be nice, but a lot of them say the lead time is like 23 weeks, 32 weeks. So who really knows what's in stock and what I can get. I'm just going to keep working on something until I run out of parts and then try to order whatever I can. If I have to spend time like searching for parts like I do all day at work, I'll lose my mind. Alright, we're on a roll tonight. We got the PDC board out without any through holes tearing off. Looks nice and crispy. I'm running out of bench space there. I gotta do another cleanup. So yeah, it's not terrible. I've seen worse, but there is some good chunky junk on here. Best way I've found is to just kind of use a sharp edge to scrape off as much as you can, and then go straight to the wire brush and just like scour this thing. If you take off the solder mask on here, it doesn't matter. I do this over the garbage can though, because I don't want to breathe this crap in. So I'm just taking a brass brush and going to town on that, just trying to clean it up. It doesn't have to be, glowing, but you want to make sure you get all that glue off. I had some stainless brushes in here. They were a little more aggressive, but I don't know where they are. But that's better. You can actually see the board, and there's not a big blob of glue on there. There's one spot that I don't like. So you still got to get in there and clean it up a little bit underneath the legs of the resistors and such. There gets some stuff trapped. But that is usually why we get failures, because these diodes get shorted out and the supply won't oscillate. So we're going to put this in our Testomatic 5000 here, which is just a sub 12, which conveniently uses the same power supply control. Not identical, but close enough. Close enough to operate. Just having this board, like, if you're going to work on these subs, you got to have a test board. There's no other way around it. Like, you'll lose your freaking mind if you don't. It makes life so easy. I can pinpoint the issues, very quickly with some degree of accuracy. The only thing I can't pinpoint is where all my stuff is. Like my power plugs and all that. I'm sure it's scattered. There we go. Scattered under the mess. I've worked on receivers before. It depends. If you're talking like a Denon or a Marantz, like all-in-one AV receiver, usually not. Those things are just a nightmare to work on. There's 5,000 screws, and schematics are hard to find, and there's just too many things that can go wrong with them, especially the newer ones where you have like HDMI and all that stuff mixed in. It's just a nightmare. Like I got two really nice Denon units, and they both work to some extent, but they both don't work. So I mean, they're in my pile of things to do, and I just have no desire to work on them just because they're overly complicated, and the amount of plugs and wires and everything is just overwhelming. And every time you test it, you got to take all that stuff out, then you got to put it all back in. So I just generally try to avoid it so I don't have to deal with it. Alright, we're getting ready to do a power supply test here. We're going to test this board. If I have power, I guess I can put the meter in the picture here. I'm just measuring at the voltage regulators. And of course you guys can't see that because the camera's at a funky angle. I guess you can kind of see it. I can see it. I'm not propping it up right now just for this. We're going current limited. And alright, so right away we jumped up to, well, you can't see it now, but we jumped up to 25 volts, so that board is good. It is oscillating the power supply, and that's all we need it to do. Let's discharge this so I don't zap myself. Practice safety first. Alright. Especially since there's bus voltage on this guy. We don't want to get shocked. Well, I don't want to get shocked. Alright, so that can go back in. We know that's good. I'm going to leave it out for now and just take these MOSFETs out next. Solder sucker's still hot. We know we have at least one bad FET, so let's take the heatsink off, get that replaced. And then we'll clean off the transformer, get all the glue off of that, and get ready to recap this supply. Where are we at here? Here's the FETs. I'm just throwing a little bit of lead on each one of these legs, just to kind of dilute this lead free. I want to do everything I can to help get these devices out without tearing pads off. And a little bit of lead solder really makes a big difference. These cheap boards really don't like to be heated up too much. Alright, that should just fall right out now. No guarantees. Well, I gotta fight the... Sometimes you get lucky and these nuts like stay in place and you don't have to get a pair of pliers to get them out. Other times you do. I should just buy a nut driver for these. It'd make life way easier. I'll put that on my to-do list. Come on. These are not the right pliers to be trying to take off a essentially Loctited screw with. So yeah, nut driver would definitely be better. And you can see we did a good desoldering job because the heatsink just kind of fell off. Alright, we'll double check our FETs. Radio Shack meter's freaking out on me. Alright, so I'm just looking for shorts. No shorts on that one. I know this other one's going to be shorted. So this guy's toast. Who makes this guy? IR, and it's a 740. I think I have some IR 740s. IR 730, IR 740. I got a few left. That's a 730. I don't have a lot of 740s left. That's no good. These are probably impossible to find now too. Gonna reuse some of this excessive blob of thermal heatsink goop, since they graced us with a couple gallons of it on here. And remember, you don't need a lot of this stuff. Really thin, light coat, all you need. Just a haze. And there's enough on the heatsink to survive. I don't know why they put so much on at the factories. I mean, I can guess it's probably because it's on an assembly line and the worker just doesn't care. He just wants to get his stuff done, but you don't need a lot of thermal goop. You gain absolutely nothing by smothering your parts with the stuff. Make sure that my heights are somewhat close, and they are not. That guy's been trimmed though, so that looks alright. Better than it did from the factory. Now these little spring clamps, you want to make sure you don't over tighten them too much because it's just a cheap piece of steel. Throw you out. That guy's bad. And we will pop our, just for the sake of checking. Well, that's glued. I'll leave it alone. Make sure it lines up and falls back in its holes there. It shouldn't require a lot of effort. If it requires a lot of effort, you gotta realign the MOSFET. We got lucky today. And then we'll bolt her back up. Actually, no, we won't. I lied. I want to get this, see that? It looks like it caught on fire. It's really not. That's just burned glue. I'm going to use my nippers and just kind of break off the chunks. And then I'll come back with the razor blade and kind of shave off what's left. Now you can leave a little bit on here. It ain't going to hurt nothing, because we're going to put silicone on there. But try to get most of it off. You don't want to cut through the tape if you don't have to. But just get some of that gnarly glue and get it off there. You can even use like a little scraper tool or something. Doesn't have to be perfect, but for the sake of being thorough, we'll get most of it off. This glue destroys my bench every time. That and that white thermal powder. Let me mute you really quick. There we go. I'm learning to not kill everybody's eardrums when I blow onto things. Alright, that's better. You know, a couple of minutes, just do a quick clean out. It really makes it easier with the heatsink off. I mean, you could do it with it on, but I mean, we had to replace one of the FETs. I can hear my dog rustling around. Dog's about to get up. It's snack time. If the dog comes downstairs, that's when I'm going to get my coffee. Alright. Make sure that our pins are in and lined up. Our new ones will stick down lower, that's okay. You can wrench down on these screws a little bit. I mean, don't tighten them enough to break the actual screw, but you don't have to be careful with these. You want these to be good and tight. You don't want your heatsink to come off and start flopping around inside your sub. Realistically, these should be nylon lock nuts. I mean, these Keps nuts or Keeps nuts or whatever the heck you call them with the built-in star washer are okay, but a nylock nut would be way better, in my opinion. Alright, put our controller board back in. Time to start soldering. Let's turn the big boy off. Turn the little guy on. Get this baby working. So I'm just going to tack in this board by one of the legs. Get it positioned where I want it. Doesn't have to be pretty, we're just tacking it in place. Then we can flip it over and make sure we get everything real good. I'm leaving the iron on the legs of these FETs just a little bit longer because I want the solder to wick up to the other side of the board. A lot of these boards, if you look at them, they run them through like wave soldering, and you don't get a good fillet on the top of the board. And some of the connections they make through these through holes, so you know, it doesn't hurt to, you know, just take the extra second, do a check, and make sure you're getting, you know, a decent fillet on the top. Even if it's just flush with the surface, that's fine. You just don't want like voids to where the top has like a crater in it. You want to make sure that the joint is completely filled. It's more important on, you know, legs that have really big traces or connected to ground planes, but or even on these little ones, you can kind of tell, like when you get good with soldering, you can tell just by looking at it. You can see the way the molten metal kind of flows down in there, and then when it starts to form like a little cone in the top, that's when you know you're good. And I think we're good. So let's see, these were 200 volt 470s. I wish I had some bigger ones to throw in there, but I don't. But these are good caps. These will work. I don't have two squatty ones, or I would use those. I could go 560s if I really wanted to. You know, if and you know, maybe that's what I'll do. You know, if I run out of parts, you can always add more capacitance. These tank capacitors, you know, you're not gonna do any damage by going up to like a 560 or even 1,000. Your inrush current will be a little bit more, so you got to be careful there. You don't, I mean, you don't want to go too big, but you know, these amps can take some added capacitance if you're in a bind and you can't get parts. You know, I'm in most cases not gonna do that unless it's like a critical job and somebody like really wants it. But you can. So you know, like I have these 560s, and you know they'll fit right in there. You can do that, or if you can't find those, you know, like I only have one of these, but you can put the little squatty ones in there too. These will work. So there are some options, but they're just not as good. Will they perform? Yeah. This snap in does not snap in. We'll have to do him later. I want to heat up my solder sucker. I'm glad this one uses a 1000 though, because I don't want to burn all my 470s on 1 amp. Let's see, let's look at his brother. Did I put the skinny ones in his brother? Yes. Alright. Since these are matched amps, I want to... Everything I did on the other one I want to duplicate. It really doesn't matter, but since I'm OCD, it matters to me. So whatever I did to the other one, I'm doing to this one. Same sizes, same everything. That way, if anybody has these both on the bench again, they'll be like, oh, hey, this guy knew what he was doing. He didn't do a hack job. For all my European friends out there, you can buy an American Klipsch and import it, and these amps will run off of 220 with one very, very simple modification. And I will highlight that in this video. I'm not going to advertise it, so this is privileged information only to my viewers, I guess. I don't really know how privileged it is, but if you would like to run an RW-12D and you purchased a United States version that's 120 volts, it has two jumpers in here. They look like resistors. They're not. They're jumpers. There's one here and there's one here. If you take those two out and you put a little jumper wire right here in the middle between them, it'll operate on 230. So that is all you have to do to make this amp work at 230 is you just put a little jumper, right? You take these two resistors out, which are actually 0 ohm resistors or jumpers, and you just jump the two center pins, and you instantly have a 230 volt amp, 220, whatever. Pretty cool. I know some people that like to run their gear at 220. It is a little bit more energy efficient. I don't know about for a subwoofer, but for higher powered equipment, higher voltage is definitely more efficient. Alright. I'm just using the solder sucker to solder these in just because I want the little bit of extra heat to get a good flow in there. Heat them pads up a little bit and let that solder, you know, wick down in there. This amp is fully functional right now. I have no question that, you know, this thing is up and running. I'm going to replace the 3 little caps on here just because it's only 3 of them and it'd be kind of crazy not to. I'm going to cut these out actually. It's always safer to cut out caps than it is to try and desolder them, if you can. Nobody's invented for me any long reach nipper cutters though. I'm still kind of sad by that. I've requested it numerous times. Sadly, none of my friends or viewers have done that for me yet. And I will reiterate for any of you creative peoples out there, I want a pair of these, but I want the tips to be about this long and super skinny so I can get way deep into areas and make cuts. Somebody make some of those. And yes, I could do it. I, you know, have the CAD software. I just don't have the time or the desire. I don't even know what they'd be called. Technician's tweezers or technician's cutters. I don't know. Precision deep reach cutters. Whatever it may be, I need a pair of them. And they don't exist. At least not in my world of Google capabilities. Maybe somebody else can find some, but I have looked and looked and looked and looked, and these Heiko ones seem to be the best. Alright. The reason I'm cutting those out is just they have bent leads on them, and I just don't want to deal with bent leads right now. It's easier to precision snip them and then use the tweezers to pull out the legs. If you can find which legs are supposed to come out. They don't always come out easy. Sometimes they do. Sometimes they don't. But when they're that bent over, I generally try to cut them first, because you're risking doing damage to the board if you do it any other way. Luckily, most of these legs are made with steel, so usually you can just get in there and, you know, a pair of steel tweezers, you can suck them right out. I mean, you can pull them out with a magnet too, I guess, if you wanted. That would work. So I take them out, then I'll put a little solder bubble on the through holes. The whole purpose of that little extra solder bubble is just to give me enough heat to and to dilute the lead to make sure I can actually clear the hole. Let's see, those two were 47 micro at 50 volts. I'm running low on these too. Probably only have 10 or 15 of those left. Double check your polarity. Square pad is positive. Most of them, the negative sides are marked, but not always. Sometimes. Just do a quick tack. Make it look nice, and then we'll flip it over and actually solder it in. Double check again. Square is your positive. Make sure that your stripe on your capacitor is in the right spot. Alright, one more cap on this guy and power supply will be good. And that's this little hidden guy back in here. That was not the right one. That was the leg of a diode. Gotta make sure we solder that back in. Alright, we gotta get this little guy that's buried in here out. 22 at 50 volts. We got some of those. (22) at 50 volts. Sometimes these are hard to get in when they're in these like little confined spaces. You gotta be kind of creative. The tweezers don't always get down in there. These pointed tweezers are kind of worthless for handling parts. These big cheapies seem to be better. Does not want to go in there. Terrible spot to put a capacitor. Alright. We will fire this guy up in just a minute here. I am mostly confident that it's going to power right up and we are going to be good to go. Clean off a little bit of that flux on the bottom. I mean, they didn't clean it from the factory, but I don't know. The spots that look absolutely gnarly, we're going to just give it a quick little wipe down, just kind of make it look a little bit nicer than it does. You can see from the factory where it reworks that, or not reworks, where, you know, wherever they soldered something in, they leave all the flux on the board, so we'll get most of the residue off. Like a little bit of it ain't gonna hurt nothing. This is not like an acid flux where it's gonna continuously eat away at the board. Alright, board should be good. This does not have the low voltage regulators on it, so we'll just check our main outs. So let's get our plug, make sure our power's off. Yeah, don't plug it into this side either. See where it says CD plus and minus? If you do that, you're going to blow up the amp. I've made that mistake before, you know, not paying attention and rushing and doing stupid things. I mean, it kind of catastrophically goes up. This cap, you know, typically explodes. So, don't do that. Power goes on this side with the two big caps. This is DC out. Alright, so I know we had no power before because there's no fuse in here. So let's see if we get our 8 volts. I wish that was easier to see. Alright, here we go. Current limited going on. See what we get. There it is. 7.9-ish. Power supply is alive. So at this point, this amp is repaired. I mean, you could just smack it back together and call it done. I don't do that, because you guys are all my friends and I want to make sure that I take care of you, so I will not give you a half-assed repair. Just doing a discharge on the big boys. These guys have discharge resistors, but it doesn't hurt to hit them. I don't want to get nailed. Alright, power supply can get set aside. Let's go on to this amp board here. And we will do a recap on this guy. Let's see, we got to unplug here. And I'm just going to pull this board. There's like, what, 5-6 caps on there and a handful on the input board. These things are really blobbed up with this glue stuff. Let's see if I can get some of this off. This glue on this one is a little extra crazy. I still don't know what this stuff is. It's some kind of like plastic. Some kind of plastic that's really hard to get off. And you gotta be careful with this stuff, because when it breaks off, it like usually shoots. I've gotten this in my eye before. It really freaking hurts. It's like getting a piece of glass in your eye. Like that one that just shot at my face. You need to wear safety glasses when you take this stuff off. Or at least don't just like look at it. You know, these clamps don't have to come fully out. They just need to be loosened. You can take them fully out if you want. It just makes it harder to get them back in. Just a few you know, turns to loosen it up, and then just pull out the mounting screws, and this guy should come right out. be prepared for the massive influx of nasty glue or thermal compound. Sorry, not glue. Alright, is it going to come off nicely? No, because the thermal bead is stuck down, so we got to take these off anyways. Lucky us. I got to get in there with the razor blade, so I'm going to get the white gunk all over my hands. It's another reason why I like Sunfire amps. They don't have any heatsink compound in them at all. They use silicone thermal pads. And they don't use any of this weird plastic bonding agent, so the screws get like stuck in and want to strip out every time. Don't get me wrong though, they still have plenty of flaws. And they still use cheap Chinese capacitors. Man, that one's really in there. Alright, let's see if we can get them off there now. There we go. Alright, let's put something down on the bench so we don't make a mess. I don't really have anything, unfortunately. I thought I had a piece of paper sitting nearby. Here, paper towel, that'll work. Nope, no it won't. Alright, we'll use our little post-it note to try and contain the disaster. I'm not going to clip these. I'm just going to go for it. The leads aren't bent that bad, and I'm going to try and just get them out. We'll see what happens. Hopefully we don't rip off any through holes. We'll see. .7, 35 volts, non-polar. This we have. There should be 2 of these, I believe. 4.7, 35, non-polar. I'm just going to do one at a time because I don't really remember the order of this. And I don't want to have to grab something to look it up. So we'll just go one by one. Good fillets on both sides. This one's sticking up a little taller than the other ones, but that won't hurt it. It won't hurt it at all. That hole did not clear. And we're just being super careful there and trying not to tear the through holes out. It's always better to cut them. I'm kind of taking a little bit of a risk here. This is a 4.7 35 volt bipolar. I mean, if you take your time and you're careful, you'll be all right. It doesn't guarantee that you're not going to rip a pad out, because these pads are extremely sensitive. I don't even know if sensitive is the word. It's just the boards are very cheap circuit boards. Alright, I think we have one more audio cap, I think. The rest should be power supply. I'll start at the bottom and work my way. Actually, yeah, I'm just going to work across the top here. Get that out of the way and start running through it. Then after this, we'll do the digital board. To get these out, what I kind of do is I try and twist them. Sometimes that doesn't work, so you can just trim the little bent lead off on the bottom. And sometimes they will come, sometimes they will not. Always a fight when the leads are bent, no matter what you do. Alright, 100 at 35 volts. That is a fat one. Do I have any skinny ones? I guess not. Some of the Klipsches, they use, 35 volts. Some of them use 25 volt. I think at some point somebody realized they made a mistake, and they're like, oh, we better up the voltage on these caps. I don't know exactly when that was. This hole is just not cleared enough. It is now. But it's always interesting to see that, which ones use which cap, and I haven't quite figured out any rhyme or reason to it yet. I don't know if it was maybe like a engineering decision to like save a couple pennies. Hope the CEO get a bigger bonus. I don't know. What I do know is cost savings are never done for the benefit of the consumer. And that might sound like a jaded comment, but the unfortunate thing is it's the truth. When designs are quote-unquote improved for cost, all they're really doing is telling the shareholders that we made more money, which in turn, helps the stock price and helps, the executives. It almost never is passed on to the consumer. And yes, I am jaded because I've worked for giant corporations, and quite honestly, they all suck. Small companies, that's where it's at. Small and private companies. Somewhere where you're not just a number to the bean counters. It's also one of the reasons why I do this, because to be honest, with everybody, I would much rather repair amplifiers than work in corporate America. I've just lost faith in anything that has to do with corporations in general. I'll leave it at that. If somebody's curious and asks me, I'll go into further details, but you guys are here for audio stuff, not for occupational rants. Alright, next one. It's going to be another 47 and then probably a 100. No, it's going to be a 100 then a 47. Close enough. So almost all these, since I didn't cut the leads, I'm having to double solder. You can cheat a little bit like you saw me there, like using the tip to kind of grab it and bend the lead while it melts the solder. Sometimes that works. Not always. 100 at 35. But sometimes you get lucky. So these caps that were in there, these Junzel caps, just looking at them, they're rated at 85C, and they put them right next to the two hottest voltage regulators on the board. So you can see why it's important to replace these caps. And I usually bend these and, bend them out a little bit to kind of get them out of the way just so they're not cooking the caps. But, I mean, these guys usually are directly up against the heat. And there's not a whole lot you can do about it, unfortunately. They have to go where they are, but you can do, a little bit of mitigation by bending the heat sinks out of the way. Try and give these things every opportunity you can to cool them off just a little bit. I'm just checking my solder joints, making sure I don't have any cold joints. These ones where they go up to the plane on top, like if they don't fully wet in, that's kind of normal. But as long as it has a decent amount of solder on the other side, I mean, you can you can pull out the high heat if you want to, and nuke it a little bit. Sometimes that helps, but not always. But as long as you have a solder going all the way through the board, it should be okay. Alright, this is a 47, and then we have, what, 3 more? 2 more. Should be a 47, a bipolar, and a 22. At 50. That cap did not smell good. I wonder if that one was leaking. It smelled like electrolyte. I don't know which one that one just was. I kind of want to test that. I think that was this one. Let's have a look at that one, just because it smelled a little weird. Could be fine, but I want to see, because I mean, it's a very distinct smell when you burn electrolyte with a soldering iron. It measures good. Close enough. Let's see about this 100. These are probably all good. That one's a little bit low. 80 out of 100. That's like right at the 20% mark. I don't know what the tolerance is on those caps. Usually, 10 to 20% is pretty common. But still, 80 is fairly low for a 100. That's either, garbage cap or end of life. So that is why we replace them. I guess there's no guarantee that the ones I'm putting in are good unless I tested all of them, and I'm not doing that. I trust that the factory is providing me with good parts if I'm buying, quality parts. If not, then I will switch brands, but I haven't really had any issues with parts not performing as they should, so. So it's 22 at 50. Polarized. Okay, I haven't checked the camera in a while to make sure I was in the viewable range there. I apologize, sometimes I don't pay attention to that and I get off camera. When I'm in the zone, that happens sometimes. So amplifier board is almost fully recapped. We have one more to go. this guy right here, this non-polar. And when that is out, we will go on to the audio control board, or the preamp. Came out nicely. Let's see, 4.735. Bipolar. I thought we had a 22 in there. I guess not. Alright. Brand new little amp board here. Should get at least 15 years out of this. Especially if it's powered off. And I always make sure to include my little card in there, a piece of paper, you know, reminding the owners to make sure you turn your equipment off when you're not using it. Don't be lazy and rely on the auto feature. This one, yeah, see this right here? This is a power switch. And if you want your amp to last 15 years, you go like this. Ready? That's all you have to do. If you want it to last 3 years, just go like that and never touch it again. It's my public service announcement for tonight. And I know I've beaten that topic to death. And I've gotten a whole array of replies. Some people don't care. Right? That's fine. If you want to waste your money, go ahead and do so. That's your right to go ahead and do that. Generally, these boards don't need to be recapped, but did I recap? Yeah, I recapped the other one, so I'm gonna recap this one. You know, if you're gonna do it, these two would be really the only two that would need to be replaced. But I really have yet to see a failure on this board. I do need to change my soldering tip though to a fine point. But I mean, there's not that many caps on it. If you got the parts and you got the time, you might as well replace them because they are these cheap Chinese caps. I usually leave this guy that's kind of piggybacked in on there. One, because it's a pain to get back in, and then you got to glue it, and it's a lot of messing around for not a lot of gain. Put my fine tip on there. And that tip gets that water really hot really fast. I mean, I know it's like 750 degrees, but still just dunking it for a second, that water is hot. So yeah, we're going to recap the digital control board. And you got to be careful with these. If you damage this board, you're done. Throw the sub away. This is the brains of the whole thing. It's got a digital volume pot, which is this guy right here. And it's got a little microprocessor over here. And that's what controls the screen and all the other functions. If you damage, you can replace the digital pots, okay. You damage the microprocessor, you're done. There is no way to repair that. So, if you're doing testing and you poke around and you put voltage where it shouldn't go, I mean, you risk blowing that guy up. So you gotta be careful. I have not yet tried to read the code off of those chips. One of these days I'll probably do that, and I'll probably find out that it's locked and can't be read. But I mean, it might be worth a shot to try and get a hex file off of one of those, just so I can repair them. but I have not yet found a way to repair these boards if you damage them. So, you know, if you're working on one of these, make sure you're being careful. This is the board you definitely don't want to tear any pads out of. You know, you want to treat this board nice. $47 at 50. And I'm using my small tip because these are small through holes, and the small tip does a little bit better job clearing them out, and it doesn't seem like I need to add any lead to it to get them out when I use the small tip. So that's it does seem to help. And again, you know, like I said, I'm terrified to damage these boards, so I try to be extremely careful. So I have no spare parts for those, and if one of those goes bad, I am on the line for it. And you know, I can probably find one on eBay and fix it or whatever, but I don't want to have to go through all that. So just be careful when you're doing anything on this board. Good, you know, use good soldering tips. Don't keep the heat on the board too long. You should be alright. I'm using pretty fine solder here to get these put back in. I find that I get a little bit better control with the fine solder than I do on the bigger stuff. I'm not going to trim any of these now. I'm just going to bend them out of the way. But we'll just work through, you know, one by one, get them all out. $22 at 50. One of these days I should go through and test all these to just confirm, you know, if I do have any bad ones. But like I said, I've really haven't had problems with the input board. It's usually always the amplifier board right by the voltage regulators, or it's the power supply. These areas where there's really no heat, they seem to be kind of unaffected. I don't know if that, you know, holds true for all of them, but at least the ones that I've worked on, I really just haven't seen many problems with. This board suffers from voltage regulator issues, though. I do know that. We'll find that out when we power it on, but you know, these 5-volt regulators here go bad. That's a pretty common failure on these. Let's see, we got one down here. These start getting harder and harder to get to also as you get down in here. $22 at 50. So most likely these 22s are filters for the power filters. Oh, I just threw my sweater in the garbage. That's no good. Now it's covered in lead. Well, these are usually just filter caps for the power supplies that go to the op amps. Kind of help keep the noise down a little bit. I think there's only a couple caps that are in the actual audio path. Somewhere on this board there's a an additional supply for the micro. I think the microprocessor runs on 3.3 volts. I don't think it's 5 volts. I'd have to verify that, but I think there's another voltage regulator on here somewhere. A little small one. Anyways, let's see. We're chugging away here. We got like 5 more to go. Doing pretty good, making good time. Little guy's loose, just didn't want to come out. These are 10 microfarad, what, 16 volts? Something like that, these tiny little things. Again, probably a waste of time to do these, but since I did them all on the other one, I gotta stay consistent. Uh-oh. There's my last 10 microfarad. Don't tell me I gotta order more caps for this thing. That would be devastating. Where did he goes over here, positive. I know I need 2 more of those 10s. Hopefully I got them in my spares. That's gonna suck if I run out of parts. This guy's gonna be pissed too because he's been waiting. Hopefully I have the parts. I do keep a little stash of random extras, so but I consume a lot of parts too. I can't help that. Like, what I go through, I go through. If I got them, I got them. If I don't, well, then I gotta get them. I guess in this case, if I am out, I'll have to overnight them. I really don't want to make this guy wait another week. I'd be pretty ticked if I had to wait this long and then somebody emailed, oh, by the way, I need more parts. My solder sucker's getting clogged. Where's my cleaning rod? Nope. You ain't gonna get in this one. Let's see, what can I jam in there to clean this? How about a capacitor leg? It's better. Alright. What is this? 47, 50 volts. I got a couple of those. Actually, if I run out of the 10s at 16 volts, I'll just put 25 volts in there. I'll go up in voltage. You can always go up in voltage. I'm not going to make this guy wait. Where did I just... There it is. It's always okay to bend the leads after you solder in. I know I've said that before, but once they're in, bend away. $22 and $50. Almost done. I know it gets really boring just watching me replace caps, but I do every video start to finish with no editing and no cutting anything out. That's how I do it. If you need instant gratification, then you gotta watch somebody else's channel, not mine. This is a documentary of serial number A307150289. Alright, we got one down in the corner there to go, and those two that are going to be an issue. I know that's really hard to see. Let's get a little light there. I'm just doing the last three caps, so it's kind of a tight area and there's not a lot of light in there, so bear with me. This is going to be hard to do because it's right up against the edge, right? Just can barely get to it. Luckily, adding a little bit of solder probably saved me. Come on out. Don't damage the board. Be nice to me. There we go. This is a forever cap. That's actually a good one. 4.7 at 50. Should have left that one in there. Yeah, forever cap. I don't know who makes forever caps, but I have yet to find a bad forever cap. It's not saying that they don't go bad, but they seem to be a fairly decent brand. I don't know who makes them or when they were made or really any information about them, but from my fairly consistent experience with them, the forever caps seem to be pretty darn good. Alright, now we got 2 10s left. Let's find some 10s. I'm hoping, oh wait, here's one. I'm hoping maybe there's one that got mixed in with my 4.7s. Sometimes I fat finger these things and drop them into the wrong bin. There it is. See? Nice. Fat fingers for the win. Just for the heck of it, let me make sure there's not any more in there. I'm just looking at my little bin here really fast. You guys probably can't see what I'm doing, but I am out of 10 microfarad 16 volts. I only need 2. I have 2. But it'd be nice to find one more just in case I need it for something. I'm just going to take a second to look at my overstock, because if not, I'm going to have to be placing orders. Let's see, what do I got in here? Not 10s. 4.7s 1, 10s at 50, 470s at 16. I got a bunch of caps in here. What are these? These are all oddball. It appears that I am out. I might have a couple in my random bin here. 10 at 25. I gotta order some. Those ones will probably be a little easier to find. 10 microfarads fairly common. But I need 2 and I have 2, so that's all that matters. I can complete this amp. I'm happy. Let's get back in there and finish these last 2 caps and then do a test. We'll start with this one that's going to be by the resistor that's going to drive me nuts. This one's always hard to get out because this little like ground, it's actually a jumper, but it looks like a resistor. This thing's always in the way. Best thing to do is to pull the cap. And then try to clear the hole. Either that or you gotta take it all off. I don't feel like pulling everything off right now. Just for the sake of doing so, I want to see what these 10s measure. I'm going to measure all of them too. I'm gonna guess they're all good, but I want to see it. I might put a couple of these aside just in case I'm in like a real bind. Oh, these are bad. Not up to my standards. Not up to my standards. So yeah, alright. There you go. There's my justification for replacing the caps. Man, these 10s are only reading 6.5. Let's see what a new one reads. It better read 10. We're pretty damn close to it. Yeah, that's a lot better. Alright, well, now we know why we put quality caps in there. And no, I will not be saving those garbage caps. I wouldn't put them in somebody's equipment, but if I was, you know, I repair a lot of other things other than just amps. Little things around the house or things for friends or, you know, non-critical things where I don't have to have, you know, a brand new reliable cap. I could use a junk cap in, but since they're way out of tolerance, we're not going to do that. We're going to throw them right into the recycle bin. We're going to double check all the polarities on here. Just because I want to make sure nothing is installed backwards. I think we're good. Each one of these has a plus mark on it, so plus, plus, plus. It's hard to see. You guys won't be able to see it. I can see it though. I'm just making sure I didn't screw nothing up. And we all look good. They all look good. Time to snip some leads and do some testing. then email the owner and give him the good news that his amps are restored to like new condition. I give no warranty if this amp works so good it blows your sub up, though. That's on you. Don't turn the volume up too high. Alright. Couple more snips. Then we gotta deal with our favorite thermal paste. I got a question too. Does anybody use the remote for these things? If you have one of these, put in the comments if you use the remote. I've never known anybody to use the remote with this. Maybe because it was like an accessory or something. And you had to buy it separately. I don't know. I just don't know anybody that's used. Oh, there's a little fiber in there or something. Get that out. Probably a dog hair. Yeah, if you're like deathly allergic to dogs, don't send me your amp. Because I can almost guarantee you there will be a dog hair somewhere on that amp. I try my best to make sure that they don't, but they do tend to go everywhere, and I can't control that. Especially since my dog likes to come and hang out while I'm working. She ain't down here tonight, which is weird, but she's probably hanging out with Mama. Alright, let's get this back together. And I want to get a test going, and then I want to get this thing boxed up and ready to go. The hardest part of reinstallation is getting the heat sinks back on. All the rest of this is pretty straightforward. This little 2x4 with the groove cut in it really helps. It's like having an extra set of hands. I love this thing. I should patent this and sell it. Alright, amp is mounted. We just got to get the heat sinks. And we will be in business. Let's see, this is the feature board. This is another thing I don't understand. Why do they have these connectors mounted backwards like that? How dumb is that? Come on, Klipsch, do better. They have the loopback cable that goes to this board in the back, so you got to crisscross the cables. How hard would it have been to just move those two connectors? I don't get it. I don't like stupid decisions like that. I don't understand. These are our power input cables. CD plus and minus. I think these go underneath there. No, maybe over. We'll figure that out later. Heat sinks. Let's do the heat sinks. Hopefully they will not hurt my fingers. Usually you gotta hold these things pretty darn tight while you're screwing them in. I'm just gonna work down the line. Shorter screwdriver would actually help here. Want to make sure we get them squared up with the devices. And we want to watch how we're tightening them. These are very easy to over tighten. You know, you want to tighten them until you just get a slight curve showing up on there. If you crank them down and bend them, they're not going to work. Or they're going to come loose on you. Again, I'm fighting the Loctite or whatever the heck they put on there. I usually put a little drop of E6000 over the screws. I do that when I put the silicone on the caps and all that, so I don't generally show that on camera, but I do put something on there to make sure that the screws don't back themselves out under vibration. Just because these clips are kind of cheap. I really like the bar clamps that they used on the sub 12s. I don't know why they wouldn't have used that bar clamp on here. I think that would have been a far superior way to hold these down to the plate. Definitely a lot easier to install. I don't know. That's out of my pay grade, but I mean the amps are extremely similar. Why would you take a superior heatsink mounting system and change it to something that totally sucks? I don't know if I have any of those bars. I usually have a few of them laying around. I don't see any readily in reach, but the bar style clamps for these MOSFETs were incredible. They worked really, really well. They were easy to install. You can get really good clamping pressure. A lot better than these things. So we got all the clamps are on. They got a little bit of curve going on to them. Not too tight. I know we don't have a fuse in here because we left a message. So let's 3.15 amp fuse. Give them a fuse. And we will get this baby up and running. Hopefully I have the fuses. That's a 2 amp. I think I'm running low on fuses. 3.15, there we go. That was my last one. Unless these are it. Nope, those are 4s. Those are probably 10s or 5s. I gotta get more fuses too, I'm out of fuses. I wonder how much those went up in price. Tell you what, I was at Home Depot the other day and I needed to buy some silicone caulk. It was like $11 a tube. I almost fell over and had a heart attack. Used to be able to buy caulk for like $3.50. Couldn't believe it. I was dumbfounded when I saw that. I mean, I know everything's going up in price, but damn, that's a lot. Especially for cheap silicone. And I use silicone on like almost every one of my projects, so I go through a ton of that stuff. Easily 3 tubes a week just on projects. Easily. And that doesn't include anything for the house. Need one more screw for brass. Oops. It helps if you don't put the power supply in upside down. Let's try that again. So what's the verdict? Is this thing going to power up and function, or is there going to be some other issue that we're going to have to fix with it? That is the question of the night. Okay, everything is screwed back down. We're going to connect our power bus, we're going to connect our AC, and we're going to connect our DC. CD plus and CD minus. We got a bent speaker terminal in there. Let's see if we can straighten that out a little bit without breaking it. The terminal's still looking pretty good shape. I might give that guy just a little bit of heat. Just because he was bent pretty good, I want to make sure he's soldered in there, so I'm going to give him a little lead from the top. There's no easy way to see that, because the amp wants to face away from me. I'm going to power up my iron again. Just because this terminal was bent so much and I put, you know, a decent amount of stress on it, a little bit of heat will do it some good. Just make sure that it's going to stick in there. Yeah, I know this is a hard area to get into, so I understand why. But I want to make sure that that doesn't have an intermittent connection, because that would suck for both me and the owner. So I heated it up and bent it over. Exactly what I didn't want to do. That's alright, we'll just give it a little more heat. Straighten her back out. That ain't gonna go nowhere. Let's check the bottom, make sure I didn't screw it up too bad. No, that looks good. That looks good. If I'm happy with it, hopefully he'll be happy with it. Alright, let's fire this up. We've all been waiting for it. Enough of me rambling on. Let's get our correct power cord, which I know I have because I had it earlier. There it is. Alright, we need audio input. We need... we'll just go to regular speaker. Regular speaker should be okay. I'm not going to go too crazy with the volume because I don't want the wife to come down here and kill me. But we will go regular speaker. If I can get it into these ports. That is kind of a reach. I don't know why they just didn't hard put the wires in there and just run pigtails out. That would have been the smarter move. I mean, I guess I kind of know why they didn't do it that way, but still, it's kind of a cheap ass way to do it. All right, my favorite little silly scope. Let's see, I'm at 37 hertz right now. And I'm about to violate one of my biggest rules. So, I'm going to actually handle this up at the top. Let's see, we'll set him there. Set this guy here out of the way. Make sure we plug our ribbon cable in the correct way. And I'm going to unplug one of the speaker terminals, and you're about to see why. Let's unplug the positive side. Nope. Let's try the negative side. Alright. And the reason for that is when I turn this amp on, the volume on here is probably going to be at 0 dB, and it's going to scare the shit out of the dog and, you know, make a bunch of noise. I don't want to make a bunch of noise. It's late at night. What time? It's 1, 2 in the morning. So, alright, let's go. Let's test this thing. Current limit starting now. That's a good sign. We have power, and we have output. And a camera ain't going to pick it up, but the volume's way up there. So we're going to crank that down. Like a -32. EQ mode is going to be flat. That's good. LFE mode is on. Good. Phase is 0. All settings are good. So now I'm going to power off. Hook my speaker up. I mean, we already know it works. We saw it on the scope, but I want to hear what it sounds like. Hopefully it doesn't reset back to 10. Sometimes it does that. If it does, I apologize to the wife. No, it stayed low. We're good. Now I can slowly crank it up without blasting. Actually, at 10, it's not that loud. But we can see on the scope here, even on this garbage scope, and I don't know, this really isn't garbage. It's a useful tool for what it is. But I mean, we have a really clean sine wave. We're at 37 hertz. Let me turn the volume down because it's going to get louder when I crank it up. Here we're at close to 193, showing 92.8. These lower frequencies, you gotta speed up the time on there. Otherwise it doesn't get a very good measurement. There we go. 28.14, and I'm giving it 27, so it, you know, the accuracy of the numbers is a little skewed. I don't know what I did to make it hold. Let's see what auto. I want the trigger like up here somewhere. I'm just messing around right now. I'm really not doing anything important. But I'm trying to get the accuracy up a little bit. I know when you get more samples on the screen, it increases the accuracy. So I'm at 27. I'm at, show me 26.8, so that's a little bit better. Just having a hard time triggering with too much info on there, but I mean close enough for I think this was 20 bucks. I don't know, for a cheap little scope like this, you can't really expect a whole lot, but I mean, it looks good and it sounds really good. This amp is done. Turn the volume down, power off, power this guy off. That's it. I'm gonna give it a minute to discharge. Hopefully it'll retain the settings. Come on, plug. Gotta be careful pulling these screens out. But I think we are there. 2 for 2. I think the owner's gonna be happy. I'm happy. And hopefully the audio community is happy. Hopefully I helped somebody diagnose some issues. I know this one wasn't really terribly exciting, but hey, they can't all be, you know, edge of your seat thrillers. Those are the ones that usually drive me nuts anyways and take 4 hours to fix, but so there we go. We'll do another brief overview of what we did. So we had a blown or a shorted MOSFET that was caused by the glue that was on the PDC board here. That was most likely causing the fuses to blow, and the rest of the amp was not operational. So we removed the glue, cleaned the board, tested the board. Board tested good. Sorry, I just saw something that caught my eye. There was like a little hole in the epoxy. It looked like there was a solder ball there, but it's just a void in the epoxy. Anyways, we cleaned the glue off the board. We replaced the caps, all the caps on this board. And then we did a test, and we're up and running. So, not terribly involved, just time consuming, I guess. But we're 2 for 2 on these amps, so that's good news. Both of them are up and running, and we should be good to go. So I think I'm gonna call it a night for tonight. It's fairly late. I want to go have a snack and chill out for a few minutes, and then go to bed. So appreciate you guys tuning in. Please remember, like and subscribe. If you have any questions, hit me up in the comments. I apologize that, if I don't get to them right away. I've been terribly busy and I haven't had time. I'm going to try and take some time out tomorrow to answer some of those, and try and catch up on some of my emails. I know I have a lot of emails I have to go through, so just bear with me. I'm trying my best to, get through this as quick as possible, and there'll be more to come. So stay tuned, and we'll see you soon.